attempt at this quick video, which apparently the last one did not work for you. Let's see if things work this time. So we're doing chapter 10. This literally is going to be, we're going to do one problem together, and then I'm assigning you another one to hand in, and then we're done. That's it for chapter 10. So normally we do a couple of sections in chapter 10, and we learn how to do regression equations, which are things that you guys did in Algebra 1 and probably Algebra 2 as well. So have your calculator ready. And we're going to be on page 529. Breaking already. Page 529. Why? Page 529. Nothing works. I swear to God. How the hell do they think we're all supposed to do online learning for like ever? We can't. It's impossible. We're going to do number 13. Okay. So when we first started school together, probably the first week of school, we talked about the difference between correlation and causation. And we even did this example about lemons and traffic fatalities. Causation. So we're going to revisit that problem right now. A few things we have to remember that we talked about back then. We're looking for an R value, and the R, why can nothing freaking work for me? The R value is going to tell us how much correlation there is in a line of best fit. So we're trying to find a line of best fit. Finding the line of best fit by hand is what we use those residuals for. I'm not going to make you do that. We're going to do it completely on the calculator. Okay, and R values, the closer they are to 1, whether it be plus or minus 1, is how well we have correlation. So a perfectly correlated point for point line of best fit, we would have a R value of 1 or negative 1. Okay, so let's see how this problem is done. Grab your calculators. I'm going to grab mine. And we're going to go and take our lemon imports and our crash fatalities and put them in our calculator. So we're going to go to Stat. We're going to go to Enter. And that data is already in here for my calculator, so you can pause and go put it in your calculator. So my L1 is the lemon import values, and my L2 is the crash fatality rate. Notice that we have X comma Y. They're lined up and they have to go with each other. There has to be this relationship here. So pause, put yours in. Okay, so now you've come back and you have your data in your calculator. Let us make the line of best fit. So you're going to go hit Stat. You're going to go over to Calc, and you want number 4, linear regression. Now, a couple things you need to do. You need to make sure that your X list and your Y list are L1 and L2. Then you need to go down to Store Regression Equation, and I want you to put Y1 in there. So to redo that, in case you forgot, you're going to hit vars, arrow over to Y vars, number 1 is function, and hit enter. There's Y1. So you're telling it to make the equation and stick it in your Y1. Now we can go hit enter, and calculate. If you do not have your R values here, it means your calculator was reset. And if you need help doing that, you're going to have to remember to go turn your diagnostics on. I'm going to show you where to do that really quickly. You're going to go to Second, Catalog. So Second, Catalog. You're going to go all the way down to Diagnostics on. It's alphabetical. And then you're going to hit enter twice. It has to say done. Okay. But if you already have that, I'll Actually, I'll do it for you because now I have to go back because now my stuff's all gone. So diagnostics on, okay. So I wanted this up and it's gone. So boom, boom, boom. Now I already stored mine in Y1. So I'm just going to hit enter, enter, enter. Okay. So you want to write down this value of this equation. So let's go do that. Now notice it says here the form that you're going to use. The equation is in y equals ax plus b form. Y equals ax plus b. Y equals ax plus b. And a is your slope. So you're going to go and take what they gave you. And so your equation is going to be y equals negative 0.003 and plus 16.49 or 5. So let's go write that down. So you have an equation of y equals ax, so negative 0.0. Oh my God. Such a pain in the ass. Let's try that one. Why does it keep doing this? 0.003. That's your A. So it's y equals 0.003x plus B, which is plus 16.5. And my negative is not there. It was negative. Okay, so this is your line of best fit. We're going to use that in just a minute. I want us to look at it on the calculator as well. So remember in this problem, in L1 is our X values, which is our lemon imports. And in L2, that's our Y value, which is our crash fatalities. So if I want to ask a question about fatalities, I'm solving for Y. And if I am looking to do, find out something about how many lemons, I am solving for X. Okay, now let's go back to our calculator for a second. I want to see this data in my graph. So I'm going to start with zoom, because my data is in my lists. And remember, I want zoom 9 to fit the stat. Now, the reason you have a line on your graph is because you saved your line of best fit, which is that equation that we just wrote down, y equals negative 0.003x plus 16.5 in your calculator. And if you go to y equals, you can actually see it in here, only they didn't even round the decimals. All the decimals are put in there for you, so answers will be more accurate. Okay, let's go take a look at what the question is asking us then for. It says, find the best predicted crash fatality rate, so find Y, in a year for which there are 500 metric tons of lemons, so in a year when X is 500. So you're going to go to your table, and it's already in here, but go and put your X in. Now, a second problem you might have is maybe you have all the numbers, 1, 2, 3, 4, 5, 6, 7, 8 in here, and you don't want that. I'm going to remind you how to get rid of that if your calculator got reset. You're going to go to second window because you want this table set. You need to turn your independent variable to ask instead of auto. So now you go back to table. You can plug in whatever number you want. So if you want to know, they are predicting the 15.1 thousand fatalities if there are 500 lemons imported. Now, yes, there's this great correlation, but remember, there is zero causation. So just because a line of best fit works, or there's a R value close to 1, or even if we use it stupidly to make predictions, does not mean that the importation of lemons affects crash fatalities. Now, one more question. What if we wanted to use this the other way around? So I have this line of best fit, but instead of plugging in 500 lemons to find the crashes, what if I want to work in the opposite direction? Well, that's fine also. Let's make up a number. Maybe now we want to say there will be exactly 17 0.2 per 100,000 crashes. How many lemons imported does that mean? Well, crash is y, so we're just going to plug y into our equation. 17.2 equals negative 0.003x plus 16.5, and we're going to solve for x. So I am going to subtract 16.5 from both sides. I don't know why I have to keep changing colors of my pen to make it work. Probably because technology sucks. Online learning sucks. I miss you guys. So 17.2 minus 16.5 is, see, gotta change colors again, is 0.7. So 0.7 equals negative 0.003x, and I'm going to divide by that number to get my final answer. And I'm going to divide negative 0.003. You'll stop me if I'm wrong. It looks like that can't happen because we got a negative number. So that means we're not importing any lemons in order to have that crash rate. If you guys get a different number than me because I'm struggling with my pen, you let me know. I got negative 233.3. And that's because I just made up that y value because that was not part of our question. Okay, unless I made a mistake anywhere else in here, which is always possible. Okay, so now all I want you to do for this homework is the next page, and you are going to do one problem for me, and it is number 24. Number 24. So that's the problem you have to do and hand in for your points. And that's it. That is all of chapter 10. We're done with that chapter.